So once again we have two linear inequalities and in this conjunction of them, so we want to solve this linear inequality and this one separately first. So for the first one we want to get all the x terms together, so I'm going to add x to both sides. That way we end up with a positive number of x terms, which makes life a little bit simpler. So that moves all the x's to the right side, so we don't want the 17, so I'll add 17 to both sides. And when we do this, we end up with 12. Negative 5 plus 17 is 12, is bigger than or equal to 7x plus x is 8x, and the 17's cancel out. So now we can divide both sides by 8 to cancel out the coefficient of the x. 12/8 is the same as 6/4, which is the same as 3 halves. 4 goes into 12 3 times, 4 goes into 8 twice. So 3 halves is bigger than or equal to x for the first inequality. Now for the second one, we want to get all the x terms together. So in this case, it looks like it makes most sense to take 2x's away from both sides, because then we get 3x minus 2x that leaves a positive x on the left. Then we don't want the 5 here, so I'll take away 5 from both sides. So when we do this, we end up with 3x minus 2x leaves x is less than, here the 2x's cancel out, and we're left with 9 minus 5 is 4. So we've already solved this one. And now we're looking for the and, this and that. Remember, and is intersection, the intersection of these two solution sets. So we'll graph a line for the first solution set and a line for the second solution set. And then for the and, the intersection of the two solution sets. The numbers involved are 3 halves, which is 1 1/2 and 4. So the smaller number is on the left, there's 3 halves. And to the right is the number 4 on all 3 of these number lines. So for the first solution to this inequality, we're looking for all x that are less than or equal to 3 halves. So that's where they're equal to 3 halves. We'll fill that in. And if it's to the left, the x's will be less than 3 halves. So there's that solution set graph. The second solution set, x is less than 4. So here's 4. X is less than 4 means to the left of 4. So it's going, everything to the left of 4 is in that solution set. Now we're looking for the and of these two, the overlap. Overlap. So here there's nothing in either of the solution sets, so there's nothing in the overlap. Here there's a solution in the second, for the second inequality, but not for the first one. So that's not in the overlap. But anything here to the left of 3 halves is in the overlap because it's in both sets simultaneously. So to graph our solution set, notice that this is in both, this point, and everything to the left. So we have this situation. Everything to the left of 3 halves, and including the 3 halves, is in the solution set. So this third line now has the graph of the solution set. And if we think of negative infinity being at the end of the line to the left and positive infinity to the right, though we don't need that one here, we can write the solution set in interval notation by saying it's all real numbers that go from negative infinity, not including negative infinity, up to 3 halves, and including the 3 halves. And in set builder notation, that's the set of all real numbers x such that x is less than or equal to 3 halves. So one thing to notice here is that the solution set is the same in this case as the solution set for the first linear inequality. And this happens because we're looking for the overlap, and notice that the first linear inequality was part of the solution of the second linear inequality. So the solution to the second linear inequality down here includes the first one. So if it has to be in both, it has to be in the smaller set because it's part of the bigger set.